Here is the area and volume question from 2015. I want you to try it first. And then when you're ready, you can listen to see how you did. So we have two equations here graphed. You have two areas. One's R and one is S. And the first is find the sum of both those areas. And to find the area between two curves, it's top subtract bottom. So it's question number 2. You can use Desmos. So I want you to press pause and go to Desmos. And I want you to put in these two equations and then press play. Alright, so this is what it would look like if you put in those equations. I want you to notice with Desmos, for the exponent on E, I need to put parentheses around it so it all stays in the exponent. If you don't use parentheses, you'll notice the minus 2x won't stay in the exponent, it'll go down beside. So we need parentheses here, so the whole thing is in the exponent. Also with Desmos, which is nice, is you can easily see what's top and what's bottom by color. So if I look here, you can see that blue is on top and then red, and then the second one, red is on top and then blue. So we're going to set this up, top subtract bottom. So we know the bounds are going to go from 0 to this number. That's going to be our first region. So we're going to integrate the find area. So I'm going to integrate. So the first one is 0 to 1.03283. And it's top subtract bottom. So the top there is blue, which is g at x, subtract f at x. And then we're going to add the second region, which starts at 1.03283, and then it ends at 2. So there's the x coordinate. So we found this right here to be 1.03283. So we have two areas from 0 to here and from here to 2. And we got to switch what's on top. So for area S now, f at x is on top and g at x is on the bottom. So it's top subtract bottom. And now we're going to type this in and get our answer. So let's go back to Desmos and let's type it in. So press INT and it goes 0 to 1.03283. And because I defined it, I can just go g at x subtract f at x, make it easy, plus another integration sign. This is 1.03283 to 2, and this is now going to be f at x subtract g at x. And you get the answer 2.004. I want you to try part B. Press pause and see if you can set it up and work at it. So region S is a solid whose cross sections or perpendicular are squares. So if I think of region S, it's here on the right. This one is f at x minus, is that right? Is that the one that's f at x minus? Yeah, f at x minus g at x. That is going to be my base of my square. So if I take the top, subtract the bottom, f at x subtract g at x, that's the base of this square that's making this volume. And then the area formula for a square is you take the base and you square it. So it's going to look like you have your bounds, and it's the area formula, dx. That's the setup. So we're going to integrate. For area S, it's 1.03283 to 2. And it's the area squared. No pi in front, right? It's not a circle. It's just a square. So no pi r squared, just the base squared. And the base, again, is top subtract bottom. So in that case, this case, it's f at x subtract g at x. And now go back to your calculator and type that in. So again, 1.03283 to 2, and it is f at x subtract g at x, and it's squared. And I get 1.283. All right, we're almost there. Okay, press pause and try the last one. And then once you've done your best effort, I'll help you through it. Let h be the vertical distance between the graphs of f and g. And it talks about 1.8. So 1.8 is going to be in this of s. So the vertical distance here from the top to the bottom is going to be f at x subtract g at x. That's going to be that vertical distance. So we first create an equation that represents that vertical distance. So that vertical distance or height is the top subtract the bottom. Then it says find the rate. That's a derivative question. So we're going to take the derivative of this. Then it says find the rate with respect to x, not time, at 1.8. And then use your calculator. So I'm going to type this in the calculator, and then we're done. Make sure I typed it in correctly. And you get negative 3.811 or 2. Both are correct. And you're done. Great job doing your work today. Not even 7 minutes. That's way too short. You can do more math today, more calculus from your prep book if you like to. Keep working. It pays off. Mr. GMAT, over and out. Till next time.